Hello students, good evening everyone. This is your KP sir on live. Now today we are going to continue yesterday's topic infiltration. Yesterday's topic infiltration we are going to continue today. Before going to start the session, first of all, a small announcement. So from 29th onwards, 29th September onwards, we are going to start a new batch of environmental engineering for GATE as well as ESC. In that I am going to start environmental engineering for 140 hours till November ending it will continue. And also geotechnical engineering is started by Abdul Rafi sir and RCC started by RP sir. So take your plus subscription as early as possible before 29th September and get your free study material and free online test series. Okay? Good evening Rahul. Good evening. So we'll go ahead now. We'll continue. So today the session number 9. I think so, hydrology for AE and AEE, session number 9. We are going ahead, continuing with respect to the topic of infiltration. We have continued. Yesterday we discussed regarding infiltration. What we discussed about infiltration? Measurement of infiltration. Is everything clear? Video and audio, is everything clear, Rahul? Rahul, will everything clear there? We'll move on now. Second method of measurement of infiltration we are going to continue. Second method of measurement of infiltration we are going to write down. Okay. Good evening, Abhinav. Rainfall simulator. Rainfall simulator. So yesterday we discussed, I think you remembered, infiltrometer. We have used infiltrometer, a ring-like structure we have provided. This is infiltrometer. Placed, attached to ground level. This is ground level. An infiltrometer, ring-like structure provided. Placed, attached to ground level. The soil strata. Soil is not disturbed, soil is present there itself. So you are allowing water to flow. If you are loading water into infiltrometer, will it cause the same effect like rainfall? You are just pouring the water like this. You are just pouring water like this. If you pour water like this into a container, rainfall is falling down from higher above the atmosphere. In such a case, if you provide the impact of rainfall, water droplets falling down from atmosphere, exerting pressure. This is ground level, water droplets falling down, drop wise falling down onto atmosphere, exerting pressure. And you are giving a water from a container to infiltrometer. You are giving the water. So both impact will be same, both effect will be same. No, na? Effect of both is different. Na? So that the same effect of artificial rainfall created. So rainfall simulator, a plot of 4 meter by 2 meter is prepared. A plot of 4 meter by 2 meter is prepared by providing rainfall arrangement, sprinkler method of rainfall arrangement. A plot of 4 meter by 2 meter is prepared. Sprinkler method, I will show you. So this is the simulated rainfall. From this nozzle, water is falling down. From the nozzle, rain water droplets falling down. Rain water droplets falling down. So thickness of 0.75 meter. Here, length of 2 meters. So, simulated rainfall condition, water droplets falling down. What is this? This is the arrangement of soil through which you want to measure infiltration. The soil strata through which you want to measure infiltration, that the soil strata arrangement is provided. The soil may absorb water, that may allow water to fall down into container. What is the fall down of container? Runoff. Collection of runoff. After runoff is falling down, collected, some amount of water absorbed by soil. That absorbed water by the soil will consider it as infiltration. So using rainfall simulator, we are going to estimate the process of infiltration. Using rainfall simulator, we are going to estimate process of infiltration. Infiltration is equal to rainfall minus runoff. Infiltration is equal to rainfall minus runoff. If possible, we'll consider change in moisture content of soil. Infiltration is equal to rainfall minus runoff minus change in moisture content. This is the plot of soil. This is the plot of soil provided 4 by 2 meter, thickness of 0.75 meter. From the top surface, water droplets are allowed. From a top tray, we are providing here a tray-like arrangement, perforated tray-like arrangement. From this top tray, water droplets are sprinkled, fall down from atmosphere to ground level, from this soil. From this soil. At one end, what you are providing at one end? Tell me at one end what you are providing? A collector, watershed arrangement. We are providing watershed arrangement. So this is catchment or watershed arrangement. What the watershed will do? Watershed is collecting runoff volume. Watershed is collecting runoff volume. So this water droplets are falling down, runoff volume is falling, and some water is getting absorbed inside the soil strata. Some water is getting absorbed inside the soil strata. So infiltration is equal to rainfall minus runoff, because that change in moisture content itself will consider as infiltration. In such a case, if you are providing in such a case, so just you consider rainfall minus runoff, and this is runoff. This is runoff. So rainfall is falling down from the top. Rainfall is falling down from the top. So rainfall falling down, entrapped in the catchment, the difference between rainfall runoff absorbed by soil, that is taken as infiltration. Clear? We'll move ahead. Done. This is rainfall simulator. We'll go ahead. Third method, Horton's infiltration. Horton's infiltration capacity curve. Horton's infiltration capacity curve. The third method. First one we discussed. What is we discussed? First one, infiltrometer. Infiltrometer two types: a single ring infiltrometer, double ring infiltrometer. Then after that we are entering into rainfall simulator. Over. Horton's infiltration capacity curve. So Horton is the scientist who has done experiments with the different kinds of soils, and he has provided a common universal curve and universal equation. Got it? He provided two. One is universal curve and second one is universal equation. So according to Horton, FT, infiltration rate at a specific time. infiltration rate at a specific time written as Ft mm per hour, time duration taken in hours on x-axis. Graph Harton's infiltration curve. Harton's infiltration curve is provided. What is going on in Harton's infiltration curve? This is Harton's curve. So what is going to be represented by Harton's curve? Tell me. Initially, the rate of infiltration is found to be very high. Initially, the rate of infiltration was found to be very high, F naught. F naught is taken as initial rate of infiltration. Initial rate of infiltration. F naught, initial rate of infiltration. Yes, correct. Decreases with the time and then constant. At a certain stage, Rahul, at a certain stage, it will become constant. What is that value of constant we can say? What is the name given to that value of constant, Rahul? FC. FC. Saturated capacity. Saturated infiltration capacity rate. Saturated infiltration capacity rate, FC. F naught is initial rate of infiltration. F naught is initial rate of infiltration. FC is saturated infiltration capacity rate. F naught and FC. So we'll consider initially it is high. How much high? Initially how much high? What is this? Vertical depth we'll consider here. So if you take vertical depth, this is FC. This is FC now. That vertical depth you will consider, that was taken as FC. This is FC. Then above FC, what is remaining? We can say F naught minus FC na, F naught minus FC. So that is initially two activities are going to take place. Soil moisture deficiency, not only infiltration, soil moisture deficiency, water is utilized to fulfill soil moisture deficiency. Good evening, Rudrajay Singh. And also along with the soil moisture deficiency, it perform infiltration. So that initially soil moisture deficiency plus infiltration, that is only will consider, total will consider it as F naught. And time goes on increasing. Rainfall occurred 20 minutes, 30 minutes, 40 minutes, 1 hour, 2 hours. Soil moisture deficiency fall down because soil is started absorbing water. So soil moisture deficiency fall down. Soil does not require water at some stage. Total water drained off towards water table only. That water which is going 100% not absorbed by soil, going off into zone of saturation, that is taken as FC. So according to Harton's curve, Ft is equal to according to Harton's curve, Ft is equal to Fc plus F naught minus Fc into e power minus kT. Ft is equal to Fc plus F naught minus Fc into e power minus kT, according to Harton's infiltration equation. This is called Harton's infiltration Horton's infiltration equation. Ft is equal to Fc plus F naught minus Fc into e power minus kT. What is Ft? Infiltration for a specific time t hour. Infiltration rate at a specific duration, specific time, tth hour. For example, rainfall occurred between 0 to 6 hour, 6th hour rainfall, 4th hour rainfall, 3rd hour rainfall. If you take F3, 3rd hour rainfall, exactly 3rd hour, not 0 to 3. Remember, it is not at all cumulative value, it is not at all added value. 0 to 3, 0 to 4, 0 to 5, like that only you can take. You can't take exactly 4th hour, exactly 3rd hour, exactly 1st hour, like that you can consider. Ft is equal to infiltration rate at a specific time, that is called tth hour. So F naught, initial rate of infiltration. Initial rate of infiltration. Fc is equal to infiltration capacity of soil. Saturated or maximum infiltration capacity. Infiltration capacity, maximum rate of soil. So remember, very important, all the three, Ft, F naught, Fc, all the three are expressed in mm per hour, not depths, rate per 1 hour, for particular specific hour, 1 hour. Infiltration rate millimeter per hour. K. What is K? Horton's infiltration rate constant. Horton's infiltration rate constant, that is taken as K, expressed in terms of per hour basis. Expressed in terms of per hour basis. K. Ft, F naught, Fc and K. T is a time in hours, no doubt. Na? T is nothing but a time in hours only, no doubt related to it. T is equal to time in hours. T is equal to time in hours, no doubt about it. Okay, done. Now we are going to utilize Horton's equation and going to determine cumulative infiltration depth. Cumulative infiltration depth. What we considered? F of T. Nothing but a total depth of infiltration. Cumulative infiltration depth is nothing but total depth of infiltration. Total depth of infiltration between 0 to T hours. We will consider F of T, total depth of infiltration between 0 to T hours. Clear? Between 0 to T hours, total depth of infiltration we have considered. Now, so how you will get F of T? You will consider F of T is equal to F naught minus Fc. I will tell you. According to the, first of all, according to the curve, I will explain you. So this is the curve. you got F naught here, and during the total duration of rainfall itself, you have determined FC steady state. So now this curve is divided into two portions. Curve is divided into two portions. This is A. This is A. A1. And the second portion, the top portion. Clear? Second portion, this top portion, we will take it. Which is a decreasing portion. Second portion, top portion, will consider A2. So two areas are there. Area of A1 plus area of A2. A1 plus A2. F of T is equal to area of Horton's curve. F of T is equal to area of Horton's curve. How you will take area of Horton's curve? Area of A1 plus area of A2. Area of Horton's curve will consider area of A1 plus area of A2. So what is area of A1? This is the time only, na? Total duration of rainfall only, na? Time T. Time T. So B into H. Area of A1 will consider B into H. Yes, very good, Rahul. B into H will take. What is B? B is a time. B is a time. H is FC. FC into T, area of A1. Area of A2, what is this height? What is this height we can take? F naught minus FC. Na? So F naught, FC into T plus F naught minus FC by K. FC into T plus F naught minus FC by K. That is considered as F of T. So this is formula 1. First formula to determine cumulative depth of infiltration. First formula to determine cumulative depth of infiltration. When it is considered, whenever you came to know steady state is attained. Steady state, saturation, soil has completed its moisture deficiency. Whenever steady state attained, use this formula. What is the meaning of steady state attained? Rainfall occurred for 6 hours, total duration 0 to 6 hours. You have calculated F6 Ft and your value of F6 Ft is equal to Fc. Then steady state attained. Got it? Value of F6 is equal to saturation, maximum capacity. Ft is equal to Fc, steady state attained. So according to this curve, steady state attained, Fc already continuing. What is the last hour infiltration? According to the curve, what is last hour infiltration? Last hour infiltration is Fc, so that Ft is the last hour infiltration, that is equal to Fc. Hello Ishrat Bhatt, kaisa hai aap? You understand? Last hour infiltration is there, not this depth. This depth is equal to infiltration capacity Fc, and that is the last hour you are determining Ft. Both values are same. Ft is equal to Fc. Both values are there. Ft is equal to Fc. Then you will consider steady state is attained. Steady state is attained. This is case 1. First condition for total depth of infiltration, cumulative depth of infiltration. Second condition. This second condition. Second condition. I will draw the curve. Based on curve only we are considering, remember carefully. Based on curve only we are considering, remember carefully. So ft is taken here, y-axis, time is taken on x-axis. Ft is taken on y-axis, time is taken on x-axis. The curve is like this. Curve is formed like this. Curve is formed like this. You got it? You understand it? As steady state is attained, here, we don't know, na? Steady state is not attained here, na? We don't know actually. But from the curve we can conclude there is no attainment of steady state. Thank you, Ishrat Bhatt. Thank you very much. You got the point. Here steady state is not at all attained within the duration of rainfall. This is F0. Maybe FC at some other location. Maybe this is FC. But rainfall ended here only. Rainfall is ended here only. So Ft is greater than Fc. Got the point? Ft greater than Fc. Ft greater than Fc. This is Ft. This is Ft. And this is Fc. Ft greater than Fc. What you can understand now? Steady state not attained. Actually, for your AE, AEE, this is not at all required because it is integration calculations. So for AE, AEE exams, this steady state not attained condition not at all required. Just for remembrance, I am saying the formula. Okay. So for numerical questions, Harton's equation they never give for your AE, AEE exams. Don't worry. Okay. So steady state not attained, Ft greater than Fc. The last hour rain infiltration is greater than saturation capacity. Last hour infiltration is greater than saturation capacity. Then how can you say now? F of t is equal to integration of 0 to t ft into dt. Harton's curve not at all required. Clearly I am saying, just for by chance if any one numerical theoretical question given regarding formula equation, numerical never come. By chance if formula provided, regarding the formula we are discussing two conditions. Condition 1 steady state attained, condition 2 steady state not attained. F of t is equal to integration of 0 to t ft into dt. What is ft? What is ft, Rahul? What is ft? Ishrat Bhatt, tell me ft. We have given in the beginning formula. This formula. This is only ft formula. This is only ft formula. At the beginning we have given formula, that is only ft formula. So integration of 0 to t fc plus f0 minus fc into e power minus kt, fc plus f0 minus fc into e power minus kt into dt. Finish. So steady state not attained condition, use this formula. Steady state attained condition, use this formula. Two formulas related to infiltration. Cumulative depth of infiltration. We have two formulas related to it. Steady state attained, not attained. We'll give you one simple question here. Rahul, ready to solve it. Simple question, very simple question I will give you. Because mostly in AE, AEE you don't have questions. Remember, again and again I am repeating, I am taking here the depth up to AE, AEE standard. Don't try to crack GATE and ASC with this depth. This is exactly required for AE, AEE depth. So time and F values. time and ft values. Ft values expressed in mm per hour. Ft values expressed in mm per hour. Time is provided. 0, 2, 4, 6, 8, 10, 12. Time in hours. Okay, time in hours. Ft values in mm per hour. 2, 5, take here 12, 8, 5, 3, 2, 2, 2. What is cumulative depth of infiltration? Question is f of t. What is the value of cumulative depth of infiltration? K is equal to 4 per hour. K is equal to 4 per hour. Time and rate of infiltration ft provided. Time and rate of infiltration ft provided. What is f of t? K value is given 4 per hour. So by observing this question, will you say steady state is attained or not attained? Shall we say it? By observing the question, shall we say whether steady state is attained or not attained? Rahul, steady state is achieved or not achieved? Tell me. This is F naught. Initial rate of infiltration, this is F naught. Clear? Initial rate of infiltration, that is F naught. Okay? Then what is FC? Already steady state attained at 2 values. 2 mm per hour, 2 mm per hour, 2 mm per hour. Values continued. What is the meaning of values continued? Values continued meaning. This is FC. FC value. Clear? Values continued. Same value continued means steady state attained. Same value continued. Same value continued means steady state is attained. Steady state is attained as the same value is going to continue. Steady state is attained. So we use first formula. Na? So F of 12, 0 to 12 hours total depth of infiltration. F of 12, 0 to 12 hours total depth of infiltration. FC into T, FC into T plus F naught minus FC by K. FC into T, 2 into 12 plus F naught 12 minus FC 2 by K. 2 into 12 plus 12 minus 2 by 4. What is F of 12? It is cumulative depth of infiltration for 12 hours. 2 into 12, 24 plus 12 minus 2, 10, 10 by 4, 2.5. Is the answer now? 26.5 mm per hour. Very good, Rahul. 26.5 mm per hour. Sorry, mm. Total depth only. It is total depth only. It is not rate. It is total depth only. It is not rate. 26.5 mm. F of 12. Total depth of infiltration 26.5 mm. So do you understand how to solve the question? Do you understand how to solve the question? Steady state attained directly. We got the answers. Directly we got the answers. Okay? I will give you one more question. I will give you one more question. the Horton's infiltration equation, the Horton's infiltration equation is given as below. The Horton's infiltration equation is given as below. Ft is equal to 8.2 plus 15.6 e power minus 2k. 8.2 plus 15.6 into e power minus 2k. Consider rainfall occurred for 10 hours. Consider rainfall occurred for 10 hours. And attained steady state. Estimate total depth of infiltration and also average rate of infiltration. Average rate of infiltration for 10 hours. So first from the equation we'll get the values. If you want to know total depth of infiltration, and it was mentioned clearly, steady state attained condition. It was given clearly, steady state attained. So no doubt. So from the equation, this is Fc na. From the equation we can write down Fc 8.2. Fc from the equation we will take Fc is equal to 8.2. What is this? 15.6. 15.6 will take F naught minus Fc na. 15.6 we will take F naught minus Fc. So F naught minus Fc is equal to 15.6. 15.6. So what is F naught now? F naught is equal to 15.6 plus Fc 8.2. 15.6 plus Fc na? Clear? F naught minus Fc is 15.6. That is going to other side. F naught is equal to 15.6 plus 8.2. Now that is 30. So that is 23.8. So 23.8 mm per hour F naught, 8.2 mm per hour Fc. 8.2 mm per hour Fc. K is given 2. This is taken a K directly will take na. 2T. You change that. It is 2T not 2K. 2T. 2T. So that is 2. K is equal to 2. Rahul, F naught is not 7.4. F naught minus FC is 15.6. What is F naught? That will be added now. Rahul. Okay, clear now? Na? It is clear now? Na? So K is equal to 2. Now, F of 10. 10 hour rainfall will consider na F of 10. FC 8.2 plus F naught minus FC, wait, FC is 8.2 into 10. Now we'll use this formula. First of all, we'll write down the formula. We'll write down the formula first so that it will be very clear for you. FC into T plus F naught minus FC by K. This is formula. FC into T plus F naught minus FC by K. That is formula. So we'll take FC. This FC value 8.2 time 10 hours. This F naught minus FC. Already known F naught minus FC 15.6. 15.6 by 2. F of 10 is equal to 8.2 into 10, 82 plus 15.6 by 2, 7.8. 89.8 mm. 89.8 mm. That is F of 10. 89.8 mm. 89.8 mm, that is taken as total depth of infiltration. F of 10. Total depth of infiltration 89.8 mm. Average rate of infiltration. Tell me. Average infiltration rate. Total depth is 89.8 na. Total depth is 89.8 na. So divided by 10. What we can take divided by 10? 8.98 mm per hour. Divided by 10 will consider 8.98 mm per hour. Average infiltration rate. Simple. Total depth by total duration. Total depth by total duration will consider. So 89.8 by 10, 8.98 mm per hour. So very important regarding infiltration measurement, what we will consider them as infiltration indices. Regarding infiltration measurement, very important, we call it as infiltration indices. So very important, we'll expect one question, numerical question also from it. There are 3 index values, W index, phi index, W minimum index. Everyone listen carefully. Phi index is very important. Remaining not at all required. Phi index is most important of infiltration indices. We'll have one question from phi index. So very important, most important related to it. Phi index is very important. Okay. We'll start. According to indices, what is the concept? According to infiltration indices, indices will consider starting to ending throughout the duration of rainfall. Infiltration is going to occur as an average rate. Average rate of infiltration, same constantly, same value. Average rate of infiltration constantly, same value throughout the duration of rainfall. Throughout the rainfall duration, according to infiltration indices concept. Very good, Rahul. According to infiltration indices concept, throughout the starting to ending of rainfall, infiltration is considered average rate of infiltration. How you will get infiltration in such a case? According to this infiltration, they will consider rainfall minus runoff minus other losses. Infiltration is concluded as a rainfall minus runoff minus losses. That is depth. Immediately depth by time will take rate, infiltration rate. So I will tell you, first one will discuss W index. W index. W index carries two assumptions. W index has two considerations or assumptions will consider. W index carries two assumptions or considerations. First of all, initial losses are important, considered. What are initial losses? Initial losses are considered according to W index. Here, according to W index assumptions, will take initial losses. What are initial losses? Interception, and depression storage. Interception and depression storage. These initial losses are considered. According to W index, two initial losses are there. The two initial losses are considered as interception as well as depression storage, which are must to consider. Initial losses. Second one, entire duration of rainfall. Very good, Rahul. Entire duration of rainfall contributes infiltration. Means starting to ending of rainfall, infiltration takes place. Entire duration, total duration of rainfall, starting to first hour to last hour, starting to ending of rainfall, infiltration will take place. Entire duration will contribute to infiltration. So what we will consider here now? W index is equal to rainfall minus runoff minus interception plus depression storage. Those are also subtracted, divided by total rainfall duration. The formula for W index. W is equal to rainfall minus runoff minus interception plus depression storage by total rainfall duration. W. Rainfall minus runoff minus interception plus depression storage by total rainfall duration. That is W. Okay. Now we move ahead towards phi index. We'll discuss the question related to, we'll discuss the topic related to phi index. Phi. It is phi index. It is phi index. Tell me. So again it carries assumptions. Neglected initial losses. The assumptions of phi index. Phi index is neglected initial losses. Initial losses not at all occurred. Initial losses not at all, unnecessary, not necessary, no need. Means you neglect interception, depression storage. effective time period is considered. Effective time period. What is effective time period? Effective time period is considered. Tell me what is effective time period? Effective time period. Important na? T. We'll take effective time period as a T. The time duration at which, the time duration during which intensity of rainfall Rahul, listen carefully. Intensity of rainfall greater than infiltration. Intensity of rainfall greater than infiltration. The time duration at which intensity of rainfall is greater than infiltration. Means rainfall occurred is more, infiltration taken is less, so that contribution of runoff is there. Contribution of runoff. How can you calculate now? Phi value. How can you calculate now phi value? Phi is equal to, very important, phi is equal to, simple, rainfall minus runoff divided by effective time period T. Rainfall minus runoff divided by effective time period T. Phi value is equal to, phi index value is equal to rainfall minus runoff by effective time period T. That is phi value. We'll go ahead, last one. How to solve the question I will tell you. Wait, don't worry. Okay, I will tell you how to solve the question. I will tell you. Next one, W minimum index. W minimum index. What is W minimum index? W minimum, when we say whenever phi is equal to W, that condition is called W minimum. When it is happened, first assumption from phi index, neglected all losses, initial losses, neglected all initial losses. Clear? First assumption, neglected losses, initial losses. No? Here initial losses considered. First assumption is taken from phi index. First assumption is taken from phi index. Then effective time period is equal to total duration. So entire duration of rainfall is considered. Entire duration of rainfall is considered. Total duration. So this is taken from W. Clear? Neglected all losses from phi index. Effective time period is total duration of rainfall from W index. So how can we write down W minimum? W minimum. Numerator is from phi index. Rainfall minus runoff. Numerator is from phi index. Rainfall minus runoff. Denominator, total duration from W index. Total duration. Rainfall minus runoff by total duration. Numerator rainfall minus runoff from phi index. Denominator total duration from W index. That is W minimum. So you can understand phi index if you solve one question. Otherwise it is impossible for you to understand. Okay, we'll give you the question. 0, 1, 2, 3, 4, 5, 6. 6-hour rainfall. 6-hour rainfall. Okay. Intensity provided. Rainfall intensity provided mm per hour. 6-hour rainfall given. 3, 8, 12, 10, 6, 2. This is a 6-hour intensity, rainfall intensity values. 0, 3, 8, 12, 10, 6 and 2. Runoff is provided. Runoff because of this is provided. Runoff due to the rainfall is provided at 24 mm. Question is, what is phi value? Estimate phi value mm per hour. So it is phi value formula we are having. Tell me. Phi is equal to rainfall minus runoff by time, effective time. Do we have effective time here? Is it provided? Effective time not provided. No? So trial 1 you consider. Trial 1. Effective time period is a total duration of rainfall 6 hours. You conclude effective time duration which is not provided now as a total duration of rainfall 6 hours. So what is the depth? Sum of intensities we can take it now. Because delta T is equal to 1 only. Uniform and delta T is equal to 1. So depth is taken as a sum of intensities. What is the depth of rainfall? Tell me. 41 mm. Na? Depth of rainfall, we will add up all the values. We'll add up all the values. Sum of rainfall, sum of intensities. Clear? 41. Now according to trial 1, we'll continue according to trial 1. Trial 1, phi is equal to, trial 1, phi is equal to rainfall value 41 minus runoff value 24 divided by effective time 6 hours. What you are getting? 41 minus 24 by 16 by 6. So what is the value you are getting, Rahul? 41 minus 24 by 6. 2.833. Very good. 2.833. Shall we take this value as phi? Is it accepted? Is this value of phi is accepted, Rahul? First, last hour. This is not satisfying. Na? I6 less than 5. I6 is less than 5. So we reject it. I6 is less than 5. So we reject it now. I6 less than 5. So we'll go ahead with the trial 2. What we are doing in trial 2, tell me. Effective time is equal to 5 hours. Because last hour is neglected. This is neglected. Only will consider 0 to 5 hours. Last hour neglected. Effective rainfall is equal to 5 hours. So phi is equal to total rainfall 39. Total rainfall 41. This 2 neglected. So 39. 39 minus 24 by 39 minus 24 by 5. 39 minus 24 by 5. 39 What is the answer you are getting? 15/5 with 3 mm per hour. Will I accept it now? 3 mm per hour. All I values either greater than or equal to 5. Okay, we will accept it. Yes, we will accept it. So 5 index is equal to 3 mm per hour. So what is condition required? Tell me, what is condition required? It has to achieve this satisfaction. All intensity values greater than or equal to 5 value. Then 5 index is said to be okay, accepted, done. Okay. So tomorrow we'll solve more and more questions related to it. Okay. Tomorrow we are going to solve more and more questions related to it. So take your plus subscription as early as possible. We are going to launch a new batch of GATE and ESC. New batch of GATE and ESC we are going to start from 29th September. Take your plus subscription as early as possible. Don't miss the session. 140 hours environmental engineering, 140 hours geotechnical engineering. No coaching center will teach you. With a sharp price, very less price. 18,000 6 months, 22,500 1 year. Along with that, free material you will get, free online test series. The lessons of industry on Unacademy now. RP sir, myself and Abdul Rafi sir. 3 from formerly working in top coaching centers in India. Now as online is needed, we want to reach more number of students. We joined in Unacademy. For any queries related to your career, related to your subject, related to anything, you WhatsApp me, pin me 8985931112. Clear? 8985931112. Thank you, Rahul Gautam. So spread the information. Unacademy is providing so many free classes, and also spread the information. New batch is going to start from 29th September. Join using my code KPCivil. Follow me on Unacademy using the code KPCivil. Okay. Thank you, one and all. Bye bye, all of you. Good night.